Hello students, hope so you all are fine by the grace of Almighty God. So here I am back with you to start a new chapter now, and the name of the chapter is Metals and Non-Metal Students. But before we start the chapter called Metals and Non-Metal Students, let's have a recapitulation of the past chapter which you have done, and the name of the chapter was Atomic Structure. So let us recapitulate for a while about atomic structure, then we move to the new chapter called Metals and Non-Metals. Done? So in atomic structure, you have learned the structure of atom, in which you have seen at the center of the atom, there is one part called nucleus, which contains what? Neutron and proton. And outside the nucleus, there are shells. Okay, there are shells. Different shells are there, okay, where the electron revolves. So at the center, whichever is present out here is called nucleus, students, and that contains neutron and proton, in which neutron is neutral, it has no charge, whereas proton has positive charge. Proton has positive charge, therefore the whole nucleus will have which charge? Positive charge. So do remember, nucleus is centrally located in an atom. Suppose this is the picture of an atom. At the center of an atom, who is present? Nucleus is present. Just like at the center of solar system, sun is there. So similarly, at the center of atomic structure, there is nucleus. And this nucleus is positively charged, we say. And how nucleus became positive, let us see here now. Neutron is neutral, it has no charge, whereas proton has positively charged. And since proton is positively charged, therefore nucleus also became positively charged. So who is responsible for nucleus to be positive? Proton present inside it. Since proton is positively charged, so nucleus is also positively charged, and it is the central part of an atom. And outside the atom there are shells. These all are called what? Shells, okay? Or we even call it by the name orbit. So shell or orbit are two-dimensional path in which electron revolves around the nucleus. The way the planet revolves around the sun, instead of planet in atomic structure, electron revolves around the, not sun, but around the nucleus. So here who revolves? Electron revolves, okay? And electron is negatively charged. So this is the rough atomic structure you have learned in the chapter called Atomic Structure, student. At the center, just like in solar system, at the center is sun. In atomic structure center, there is nucleus, which is positively charged due to the presence of proton. Since proton is positively charged, so nucleus is also positively charged, whereas neutron is neutral. And outside the nucleus, there are shells or orbits, just like in solar system. But their planet revolves. Here, electron revolves, which is negatively charged. So E means electron, minus means negatively charged. And the path in which electron revolves around the nucleus is called shell or orbit. Done? Now, suppose there are 18 protons. They will remain inside the nucleus. Suppose there are 18 neutrons. That will also remain inside the nucleus. So there are 18 protons inside the nucleus. Let us assume there are 18 protons. And let us consider there are 10 protons. There are 10 protons inside the nucleus. Okay, and there are 10 neutrons inside the nucleus. So there are 10 protons inside the nucleus and there are 10 neutrons inside the nucleus. Hope so you all are understanding? There are 10 protons inside the nucleus and there are 10 neutrons inside the nucleus. So suppose there are 10 electrons in the shell. 10 electrons are in the shells. But in which shell how many electrons are present? How to know? Will there be 2 electrons? Here will be 3, here will be 5, total 10. Or here will be 5, here will be 3, here will be 2, total 10. Or all 10 electrons will be in the first shell, whereas other second shell and third shell will be blank. So we should know the distribution of electron, okay? And that distribution of electron is known by the name electronic configuration. So what is the meaning of electronic configuration? The distribution of electron is called electronic configuration, students. So when you distribute the electrons, that is called electronic configuration. So distribution of electron in the shells. So when you distribute the electron, first shell, second shell, third shell, fourth shell, fifth shell, it goes on. So when you distribute the electron in the shell, that is called electronic distribution, or we call it by the name electronic configuration. And the rule is like this. Whenever you have to remember, do remember this, that in the first shell you can put only 2 electrons, not more than that, maximum 2. In second cell we can put 8, in third cell we can put 8, in fourth cell we can put 18, fifth cell we can put 18, sixth cell we can put 32, and in seventh cell also we can put 32. So this is the rule to be remembered. So whenever you fill up the electrons, no students, you cannot fill up randomly in the shells. You need to know the numbers. So how to fill up? First shell 2 electrons, second cell 8, third cell 8, fourth cell 18, fifth cell 18, sixth cell 32, seventh cell 32. So 2, 8, 8, 2, double 8, double 80, double 32. Check, very easy to remember. 2, then double 8, double 80, and double 32. 2, double 8, double 80, double 32. That means whenever you put electron in the first cell, maximum you can put is 2, not more than that. In second cell you can put is maximum 8. In third cell also you can put maximum 8, and in fourth cell you can put is 18. In fifth cell you can put is 18. In sixth cell you can put is 32. In seventh cell you can put is 32. So you have to remember this rule. So if you know this rule, students, it will be very easy for you all to know how to distribute the electrons. And with the help of that, we can identify the elements. What kind of elements? That we'll see later. Okay. So do remember this. And if you want, you can take the screenshot of this. Okay. And you can make a picture in your note copy. So you can make a picture in your note copy after you take the screenshot of this. So I am drawing this because I have given you a rough explanation. So now look out here. In atomic structure, at the center there is nucleus which is positively charged due to the presence of proton. Neutron is neutral. It has no charge. Outside the nucleus there are shells or orbit where electron revolves around the nucleus. So suppose there are 20 proton and 20 neutron, then how many electron will be in the shell? 20. But 20 cannot be put in the first, second or third. You have to distribute by this pattern. Okay. So let us distribute the 20 electrons. Then here will be how many? How much you can put in the first shell? Not more than 2. In second cell, how much you can put? 8, not more than that. In third cell also, how much you can put? 8, not more than that. Now out of 20, how much is gone? 10 plus 8, 18. 8 plus 2, 10 plus 8, 18 is gone. But you have to distribute 20 electrons. But how many is only gone? 18. So how many is still left with you? 2 is left. Because out of 20, you have already distributed 18 electrons following this rule. First 2, then 8, then 8, done. Now out of 20, how much is left with you? 2. Now you have to put in the fourth cell. In fourth cell, how much we can put? 18. But we don't have that much left. How much is left with you? 2. So that you put in the last shell. And the electronic distribution of 20 electrons will be 2, 8, 8, 2. In between, we write, when you distribute the electron, we must write comma in between. And in the last shell, how many electron is coming out here? 2. And this last shell is also known by the name valence shell. We call outermost shell. The last shell is called outermost shell. This last shell is called what? Outermost shell. Also known by the name valence shell because it indicates valency of an element. So for that element, valency will be 2 because it is coming 2 electron in the outermost shell. So do remember, student, the last shell of an atom is called outermost shell, also known by the name valence shell because that indicates valency of an element. So if you have to distribute 20 electrons, it will be 2, 8, 8, 2. So 2 in the valence shell, outermost shell, makes the valency of that particular element as 2. It's a rough example to you all. So hope so you understood a little bit about atomic structure so far. If you want, you can take the screenshot of this to make this picture, or you have already made it in the chapter called atomic structure. Now students, you have to remember this configuration part. Suppose if I say sodium atomic number is 11, it will be given to you, okay? Now distribute it. Means you have to distribute it. Okay, sodium atomic number is 11. So how you are going to distribute the electrons? Atomic number is 11, now you have to distribute the electrons. Follow this rule again. First, how much to put? 2, you have put. In second, how much to put? Maximum 8, I have put that. Now in third, how much we have to put? 8. But stop for a while and check here. Atomic number was 11. Out of 11, how many electron is already gone? 10. 11, you have to distribute, but 10 has already been gone. So how much is left? 1 is left with you. Now you can see you can put here 8 in the third cell, but how much is only left with you? 1. So that you put out here. And this will give you the electronic configuration of sodium, students. So check here again once. Sodium atomic number is 11, means it has 11 electrons. And you have to distribute 11 electrons in the shells. So in first cell how much to put? 2, that I put out here. In second cell how much to put? 8, that also I put out here. Now when I put 2 and 8 out of 11, 10 is gone. So how much is left with you? Only 1. Isn't it? Only 1 is left with you. Now though the third cell has to put 8 electron capacity, but how much is only left with you? 1, that you put in the third. So if there is 2 also, you put here 3, 4, 5, 6, till 8 you keep on putting out here till 8. But once it becomes 9, you have to put comma and you have to put in the fourth cell, whose capacity is 18. Done? So similarly, let us do for magnesium then. Atomic number is 12. So the configuration, how to distribute electrons, electronic configuration. First 2, then 8 as usual. First 2 and 8 done. Now out of 12, 10 is gone. Out of 12, 10 is gone. How much is left with you? 2 is left. And in third you have to put 8. But only how much is left with you? 2. So that you put out here 2. Now we go with the next, that is aluminium. Aluminium symbol is Al. Atomic number is 13. So how to distribute 13? First how much to put? 2. In second how much to put? 8. Now in third you have to put 8 again, as per the rule is concerned. But out of 13, 10 is gone. 8 plus 2, 10 is gone. How much is only left with you? 3. And here its capacity is 8. So you can put 3 inside it. So it becomes 2, 8, 3. Altogether 30. 2, 8, 2 altogether 12, 2, 8, 1 altogether 11. Done? Now let us see for calcium, whose atomic number is 20. Calcium, Ca is the symbol for calcium, atomic number is 20. Now let us do the configuration of that again. Atomic number is 20, so first cell we can put is 2, in second cell we can put is 2, in third cell also we can put is 8. You can see 2, 8, 8. Now add all of this, 2, 8, 8 makes it how much? 18. 2, 8, 8 altogether makes it 18. You have 20, out of which 18 is gone. So how much is left with you? Again 2 is left. So fourth cell you have to put 18. Because we have finished first, second and third cell, now we have to go to the fourth cell. You have to put 18. But how much is only left with you now from here? Out of 20, 18 is gone. How much is only left with you? 2. That you put in the fourth cell. Okay, and for calcium, this becomes the last cell, the valence cell. For aluminum, this becomes the last cell, valence cell. For magnesium, this becomes the outermost cell or valence cell or the last cell. Similarly, for sodium, this becomes your last cell, outermost cell or the valence cell, students. Now let us go for another one. Let us go with potassium. Atomic number is 19. So you tell me now, how much to put in the first cell? 2. In second cell, how much again we have to put? 2 or 8? 8. In third cell, how much we have to put? So out of how much here? 19. 10 is gone. From 19, 10 is gone. What is left with you? 9. So many students put 9 directly like this. So 2 plus 8, 10 plus 9, 19, matching. But what is the capacity of the third cell as per the rule is concerned? 8. So you have put 9, which is wrong. You can put less, but not more than 8. Because maximum has to be 8 in the third cell. So I'll remove this and I'll write here 8. Now it's matching with this 2, 8, 8, 2, 8, 8. Now here 10, 8 plus 2, 10 plus 8. 18 is gone. So out of 19, if 18 is gone, how much is left with you? 1. Though the capacity of fourth cell is 18, but only 1 is left with you, that you put in the last cell. Done? So this is how we do the electronic configuration or the distribution of electron. You can see another name is electronic configuration by this rule: 2, 8, 18, 32. Okay, and you should not forget this rule. It's very important for you all to remember. So let us go for carbon, whose atomic number is 6. Carbon symbol is C. Atomic number is 6. So how to distribute? First, how much to put? 2. So as soon as you put 2, out of 6, 2 is gone. How much is left with you? 4. In second, you can put 8, but it is only 4. So you can put 4 out there. Why? You cannot put more than 8, but less than 8 you can put. So similarly for nitrogen, and 2 plus 4 makes it 6. Atomic number is 7. So let us do the configuration again. 7, first cell you put 2 again. Now in how much is left? Out of 7, 2 is gone. Out of 7, 2 is gone means 5 is left. And though the capacity of second cell is 8, but you have only 5 with you, so that you put in the second shell. But you cannot put more than 8, but you can put less than 8. So 5 plus 2 makes it 7. Now let us go for oxygen, whose atomic number is 8. So in first cell, how much we are going to put? 2. So out of 8, 2 is gone. Now how much is left? 6. That you put in the second cell. How long you keep on putting in the second cell? Unless and until it becomes 8. Once it becomes 8, then you will use third cell, whose capacity is again 8. So once it becomes 8, again you will use fourth cell, whose capacity is 18. And once it becomes 18, then you use the fifth cell, whose capacity is again 18. And once you fill up electron in the fifth cell also, then you use sixth cell, whose capacity is 32. And lastly, you fill in the seventh cell, whose capacity is again 32. So here, this is how we do the configuration. Let us try for one more. Chlorine. Chlorine symbol is capital C and small l, and your atomic number of it is 17. So let us do the configuration. So how much to put in the first cell? 2. Done. Now in the second cell, how much maximum we can put is 8. Done. Now out of 17 you can see here, out of 17 already how much is gone? 8 is gone, 10 is gone. 17 electron you have to distribute, and you have already distributed 10 electron, 2 in the first cell, 8 in the second cell. So out of 17, 10 is gone. So how much is left? Out of 17, 10 is gone. So how much is left? 7. In the third cell, capacity is 8, so you can easily put 7, because third cell capacity is also 8. So you can easily put 7, and the configuration becomes 2, 8, 7. If you add them all, it becomes 17. So this is how we do the electronic configuration in the chapter called atomic structure, students. Now, after this you can even find the valencies, okay? You can even find the valencies of these all elements. You can even find the valencies of these all elements. So those who have 1 electron in the outermost shell, their valency is 1. Those who have 2 electron in the 1 electron in the outermost shell means valence shell, so valency is 1. 2 electron in the outermost shell means valency is 2. 3 electron in the outermost shell means valency is 3. 2 electron in the outermost shell, the last shell, valence shell, the valency is 2. 1 electron in the outermost shell, valence shell, so the valency is 1. So if there is 1 electron in the outermost shell, valency will be 1. 2 in the outermost shell, valency will be 2. 3 in the outermost shell, valency will be 3. Therefore, this outermost shell electron indicates valency. Therefore, we even call it by the name valence shell. Now, 4 in the outermost shell, so the valency will be 4. Okay? But this 3 is little bit different than that. Those who have 5, 6 or 7 electron in the outermost shell, you have to be very careful with them. Okay? You have to be very careful with them. Those who have 5, 6 or 7 electron in the outermost shell. I repeat again for the last time, pay attention. 1 electron in the outermost shell, valency 1. 2 electron in the outermost shell, valency 2. 3 electron in the outermost shell, valency 3. 4 in the outermost shell, valency is 4. But those who have 5, 6 or 7 electron in the outermost shell, those who have 5, 6 or 7 electron, 5, 6 or 7 electron in the outermost shell, to determine their valency, we have to make it 8. Now already here is 5. By adding how much you can make it 8? 5 plus how much is 8? 3. So the valency will be 3, because 5 plus 3 is 8. 6. By adding how much it can become 8? 2. So 6 plus 2 is 8. 7. By adding how much you can make it 8? 1. So 7 plus 1 is called 8. So this is how we get the valency for the element which have either 5 or 6 or 7 electron in the outermost shell. So I repeat again for last time, students, and it is a good opportunity to you all. If you can understand in one go, you can repeat the video. Done? So those who have 1, 2, 3 or 4 electron in the outermost shell, their valency will be 1, 2, 3, 4 only. But those who have 5, 6, 7, those who have 5, 6 or 7 electron in the outermost shell, 5, 6 or 7 in the outermost shell, to determine their valency, in that number, by adding what? It becomes 8, you have to check. So here is 5. By adding how much it can become 8? 3. So valency will be 3. Here is 6, by adding how much it can become 8? 2. So valency is 2. Here is 7, by adding how much it becomes 8? 1. So the valency will be 1. So this is very important by you all to remember, okay? Others to you all understood, I guess. So if you want, you can take the screenshot of this and you can make the note of each students. And this is for you. Thank you very much. I hope it's done. Now, students, so before we proceed further in the chapter, now you have to remember this. Elements means what first, okay? Elements means what? We have already learned about this, if you remember, students. So I like to say it is a pure substance. It is a pure substance made up of only one kind of atom. Okay, so if anyone says what is element, you have to say it is a pure substance made up of only one kind of atom. So if a pure substance is made up of only one kind of atom, and we call them elements, and there are 118 elements. Okay, you have to remember the total how many elements are there. 118 elements are there. 118 elements are there total. Now these elements has been classified into 4 types. Types of elements has been classified into how many types? 4 types. One is called metal. One is called your non-metal. Okay. One is called your metalloid. And one is called your noble gas. Noble gas. So these are the 4 types of elements. So out of 118 elements, some of them are metals. Out of 118, some are non-metal, some are metalloid, and some are even noble gas. Now let us see what is metal then first. So these are those elements we say. These are those elements we say which either have 1 or 2 or 3 electrons in the outermost shell. In the outermost shell. In the outermost shell. So students, those who have 1 or 2 or 3 electrons in the outermost shell, also known by the name valence shell. So those who have 1 or 2 or 3 electrons in the outermost shell or valence shell are referred as metal. You can see from here, students. Sodium has 1 electron in the outermost shell, magnesium has 2, aluminum has 3, your calcium has 2, potassium has 1. So from here to here can be referred as metals. Okay? Why we consider them as metal? Because metal either have 1 or 2 or 3, 1 or 2 or 3 electron in the outermost shell. So metals are those elements which have 1, 2 or 3 electron in the outermost shell, also known by the name valence shell. Do you remember that? And the example of those metals are magnesium, sodium, magnesium, aluminium, calcium, potassium. Potassium symbol is K. Now let us see what is non-metal then. Those who have 4 or 5 or 6 or 7 electrons, okay, in the outermost shell, those who have 4 or 5 or 6 or 7 electrons in the outermost shell, also known by the name valence shell, are called non-metals. So metal usually have 1, 2 or 3 electrons in the outermost shell, students. Examples is sodium, magnesium, aluminum, calcium, potassium. Similarly, non-metals are those we say which either has 4 or 5 or 6 or 7 electrons in the outermost shell or valence shell. For example, you can see carbon has 4, nitrogen has 5, oxygen has 6, and chlorine has 7. So those who have 4 or 5 or 6 or 7 electrons in the outermost shell, we call them non-metal. So therefore from here to here can be referred as what? Non-metals. Okay. So from here I can isolate this way, students, to you all. Sodium, magnesium, aluminum, calcium, potassium are the examples of metal. Why? Because they have 1, 2, 3 electrons in the outermost shell. Whereas carbon, nitrogen, oxygen and chlorine, they have 4 or 5 or 6 or 7 electrons in the outermost shell. So we can refer them as non-metals. Okay. So example of metals are here, example of non-metals are here. So slowly from atomic structure chapter, we are entering towards the chapter called metals and non-metals. So do remember the definition of elements. There are 118 elements in total, and these are the 4 types of elements in which I discuss about metal with you. Then non-metal. Metal has 1, 2, 3 in the outer motion. These are the examples of it. Non-metals have 4, 5, 6 or 7 electrons. So these are the examples of it, from carbon to chlorine. Now what is metalloid? Metalloid we cannot isolate with the help of electronic configuration. Do remember. Excuse me. Metalloid we cannot differentiate with the help of electronic configuration. So directly we say like this then. What is metalloid? Okay. These are those elements which have the properties of both metals and non-metals. Both metals and non-metals. So those who have the properties of both metals and non-metals, we call them metalloid. So they have 1, 2, 3 electrons in the outer molecule. They have 4, 5, 6, 7 in the outer molecule. But by that way, we cannot isolate metalloid. So do remember, if anyone asks you the definition of metalloid, what you have to say? These are those elements which have the properties of both metals and non-metals. If the element has the property of both metal and non-metal, we call them metalloids. And there are many examples of it. One of them is boron, symbol B. Another one is silicon, symbol capital S, small I. Another example is antimony, capital A, small s, SB, capital S, small b, and so many others, but 3 examples is enough for you to remember. There are many other examples in the book given, okay? But if you remember these 3 is more than enough. So remember these 3, it's more than enough. Now we'll discuss about noble gas. Hope so you have taken the screenshot of this. So it will be easy for you all to copy later on. Please do the screenshot. Thank you if you have done so. So I am going to discuss about is about noble gases. Okay. Now let us go with noble gas. So I am doing somewhere out here for noble gas, students. Noble gas. These are those elements which have stable electronic configuration. Stable electronic configuration. So the 4th type of element is metalloid and noble gas. How we did say it as noble gas. These are those elements which have stable electronic configuration. And what is the meaning of this stable electronic configuration? Let us see now. These are those elements which have stable electronic configuration. But what is the meaning of stable configuration? Let us see. That is, i.e. means what? That is duplet. Means having 2 electrons. Having 2 electrons in the first shell. Having 2 electrons in the first shell. And octet. Means having 8 electrons in the last shell. Okay, students. So do remember, noble gas are those elements which either have they have stable electronic configuration, and the meaning of stable electronic configuration is duplet or octet. So duplet, octet actually means stable electronic configuration. And duplet means having 2 electrons only in the first shell, and octet means having 8 electrons in the last shell. It's called noble gas. Let us see one example of it then. Helium, symbol is He, and its atomic number is 2. And another one you can give is neon, and capital EON, neon, symbol capital N small e, whose atomic number is 10. So let us do the configuration. So since the atomic number of helium is 2, So how will you distribute the electron in the shell? So rule you remember, 2, 8, 8, 18, 18, 32, 32 is the rule. So 2 is the atomic number, so you put only 2 in the first shell. 2 is gone, so no other electron is left, so that much. Whereas out here the atomic number is 10, so how to distribute the electron? In first shell how much to put? 2. In second shell how much you will put? 8. And 2 plus 8 makes it 10. Done? So since it has 2 in the outermost shells, the first shell, so it is duplet. Since it has 8 in the last shell, so it is what? Octet. So it has 2 in the first shell, so helium is duplet. It has 8 in the last shell, neo, so it is octet, and both are stable configuration. So therefore the example of noble gas is helium and neon. So if you remember this much is enough. So in this portion what we have learned student is about atomic structure a bit, then I will enter towards the chapter called metals and non-metals from now on. So do remember there are 4 types of elements, which are the pure substance made of only one kind of atom, and there are 118 elements. Out of 4 elements, I discussed a little bit about metal, non-metal, metalloid and noble gas with some examples. And I said you only whom we cannot find through the electronic configuration is metalloid. Done? Now on, we'll discuss deeply about only 2 elements, that is metal and non-metal. So in my next class, I will be discussing only about metals and non-metals, because the chapter which we are going to start is metal and non-metals. So thank you very much for today, students, and it was an introductory class with you all. You have to remember whatever I have explained to you so far in this class. Now we'll discuss about 2 types of element from next class, that is only about metal and non-metal. Whereas for metalloid, remember the definition and example. Similarly for noble gas, do remember the definition and example. Remember the definition and example for noble gas. Remember the definition and example for metalloids. Whereas for metal and non-metal, we will be discussing about these 2 in detail from next class onwards. Thank you very much. So please take the screenshot of this and make the note from there. Okay? Thank you.